Okay, this video is just insulin secretion. So this is a pancreas beta cell. What happens is after eating a meal, you have increased glucose. It'll be coming up, absorbed from the gut into the portal vein, and it goes past the pancreas. And the pancreas senses the glucose in proportion to the amount of glucose in the blood. The type of transporter on the pancreas plasma membrane is a glucose type 2 transporter. So it allows the glucose to come into the pancreas cell. Once it comes into the cell, the glucose undergoes glycolysis, then it goes into the mitochondria through Krebs cycle, and then there's electron transport on the intermitochondrial membrane, and that produces ATP. The ATP is then recognized by the potassium channel. It's called the ATP sensitive or ATP gated potassium channel. The more ATP that is made, the more this channel is blocked. Under resting conditions, the potassium exits the cell through this potassium channel, and that, with positive charge exiting, it makes the plasma membrane gradient more negatively charged, so the cell is polarized or hyperpolarized. It'll have a resting membrane potential, similar to other cells. Let's say in the ballpark of negative 65 millivolts. That or negative 70 millivolts. Just call it negative 65. I find that easier number to work with. Okay, so anyways, nothing happens. The cell's at rest. However, when you make all this ATP, the ATP blocks the K plus channel, ATP sensitive K plus channel, potassium channel. Now the K plus cannot exit the cell. This leads to the plasma membrane becoming progressively depolarized, meaning that it becomes more positively charged inside the cell. And then you have a voltage-gated calcium channel. So in a sense, you depolarize this membrane. And now the voltage-gated calcium channel is activated. This allows calcium to flow into the pancreas beta cell. When calcium flows into the pancreas beta cell, you have increased concentration of calcium in the cell cytoplasm. That causes the vesicles that have the storage of mature insulin to then travel to the plasma membrane and merge with it and to release insulin into the blood. This grading of the response in proportion to the amount of blood glucose leading to the proportion of ATP, leading to the proportion of the amount of calcium, enables a graded response. So basically, the more glucose in the blood, the more insulin is going to be released into the blood to then help that glucose be pushed into skeletal muscle, for example, to go where it needs to go. So this is the mechanism by which the pancreas beta cells release insulin. And what's interesting about it is it's like so many other cells, the main thing that they do is dependent on calcium entry into the cytoplasm. And you can also remember, we talked about this before, when you have a high dietary sodium, excessive dietary sodium, you dissipate the plasma membrane potassium sodium ATP pumps, and that leads to accumulation of sodium inside the cells and a dissipation of the sodium battery gradient across the plasma membrane, with the net result that you'll have more calcium in the cytoplasm, and cells will have a tendency to be more tonically active. So pancreatic beta cells will release more insulin in a way that you don't want. You're releasing a little bit too much insulin with high salt diet. So we'll just keep that in mind. That'll come up later, and that's part of the mechanism by which high salt diets can contribute to worsening of insulin resistance. Of course, high excessive dietary fat, especially sat fat, is the main reason for insulin resistance, but just good to know that excess dietary salt, sodium chloride, also causes a little bit of insulin resistance as well.